So we're going to be talking about HTTP broadly, and then we're going to talk about a tool called man-in-the-middle proxy. There's a lot of tools like this one. This one's got a few neat features that we'll go into. There's no slides, so first we're going to be talking about HTTP, then man-in-the-middle proxy. So it's all going to be examples. I'm recording it. Hopefully it'll turn out. But if anybody has questions, raise your hand, let me know. If anybody wants to try something, let's try it. This will be interactive. I'm not watching Slack or Zoom, so if anybody in the room wouldn't mind doing that, I'd appreciate it. So let's start with HTTP. Now, we all use this day in and day out, but it's one of those things that's kind of easy to use without knowing too much about it. A lot of our tooling is going to abstract out the details of HTTP. And I think it's useful to dive into the details of HTTP for solving certain kinds of problems. The HTTP spec is not huge. This is the spec right here. So printed out, it clocks in at 100 pages, give or take. Yeah, 100 pages. So it's something that you can read in a couple of days, and it's something that's also real skimmable. So there's something you want to look up if there's a detail you want to know. It's well worth diving into, and it affects both server-side and client-side developers, and I'm going to hopefully try and talk about a little bit of both today. So one of the interesting things about HTTP is it's all text. Everything that goes in and out is all text, and that makes it really easy to just kind of mess around with kind of script. There's not a lot of gotchas in terms of formats and encoding and that kind of a thing. So, for example, you can just play around with it at the CLI. So if we use netcat, if you're not familiar with netcat, this is a common Unix utility that just starts up a server listening on a port, and anything that comes through that port, it will output to the console. So if we start listening to netcat on that top terminal, and then we make a curl request for localhost port 8001.
It's just a little closer.
Thanks. Is that a little better? If we make a request for port 8001, so oh sorry, I should type that out and not use my alias. So if you make a curl request to that URL directly, you can see that the thing that you get back here on that top terminal is the text that curl sent to make that request. And that request part of the request response cycle is just these text strings. Get the path, the HTTP version, and then any headers. And then there's a blank line that separates the headers from the body, and that's it. That's all there is to talk about here. So one thing that you can't see at the terminal is the new lines are delimited with control line feeds, not just line feeds. The HTTP spec says that clients should be error tolerant if you just use line feeds, but the spec specifies that you're going to want to use both. So keep that in mind, and that's going to be a running theme. Since we're talking about the web, the exception is going to be the rule, and it's going to be Wild West in terms of what various clients implement. So, all right, so we've got these headers, the request, the blank line, and now we need to give it some kind of response. So we can just give it a response. We can say HTTP 1.1 200 OK, so there's a response. We can put other headers here if we wanted to, like custom header. And then, again, blank line, response body here. And then we end the response. So you can see curl got that back. If we do that again, but tell curl to be otherwise quiet, but output headers. Start the server. Do that again. Oop. you can see that curl gets that back. So curl has separated out the headers and the body. Curl is just parsing that based on that blank line. So if you wanted to do that, say hypothetically speaking, you were broken in some fundamental way, and you thought it was a good idea to write a GitHub client library in Bash shell, like I did once. You can do this in awk or Bash shell, and you can separate these out, and you can parse a response body just by looking for that blank line. There's really nothing to it. So it's well worth doing if you ever want to, say, script a custom response, and we'll get into why you might want to do that, especially here at MX when you're troubleshooting customer situations. It comes up. So any questions about the request response cycle before we talk more about individual headers? Okay. So as we've seen, sort of from the CLI here, the headers are not required. You need that that preamble specifying the HTTP version. You need the response code, and that can be whatever. But after that, it's just the response body. So no headers are required, but you're going to see a lot of headers by default, as you guys know. So we switch over to Robin Hood and Longbow. Oop. As you guys are well aware, the browsers in particular, but most HTTP clients are going to add a bunch of request headers. Let's see. The response doesn't need to end immediately. You can have different kinds of responses in that request response cycle, where the response body can stream in. It can stream values over time. You can stream multi-part responses where you've got this attachment followed by this attachment, so the connection can stay open, and you've got headers to control that connection. But if you ever need to do that, that's called long polling, and there's a really neat specification which is on its way out, which makes me sad, called server sent events, which is long polling in an HTTP spec. So if you're good with HTTP, like we talked about, the spec for server sent events is tiny. You can read it over a lunch, and it's way simpler than working with WebSockets, for example, and gives you that kind of real-time view. It's a lot of fun to work with, and it's one of those things that you can just write up. Like, you don't need big, fancy frameworks or libraries to do it for you. You can just output text to the response socket and call it a day. All right, so. Let's see, a few headers that we should talk about are going to be cache control headers. Those are going to be the big ones that browsers and proxies are going to deal with. And proxies, generally speaking, are pretty good at adhering to the spec. There's always going to be exceptions to that. But generally speaking, they handle the spec fairly well, so that, there's proxies spread across the wider web, and they do their thing, kind of transparently in terms of abstracting out endpoints or speeding up endpoints or all of the things that the proxies are used for. But browsers, on the other hand, it's Wild West in terms of what browsers are going to do with what headers, especially with caching. Browsers are kind of their own thing when it comes to caching. Like everything else in browsers, they're kind of converging to be more similar to each other, but it's still pretty crazy. So some of the cache control headers that you're going to run across are like when this resource expires, or a hash that's associated with a resource called an e-tag. And these are really useful for saying, I've already got the resource, is there anything new? Like if you do a conditional get, they're called a conditional get. So rather than doing a full get request, where you get a URL and you get everything that comes back from that URL, you can do what's called a conditional get. You can say, this is the last thing that I saw, right? This timestamp or this this hash is anything new, and the server can do a really lightweight check and give you back a lightweight response, usually an empty response saying, "Yep, you've got the latest," or "No, here's the newer version." So caching is a big deal, and when you're troubleshooting something, like you're working with a web service and you're troubleshooting something, it's key to dive into these headers and look to see, what is the browser sending? What is my client sending if it's not a browser? And what am I getting back? And to really scrutinize those, because they can make a big impact on the behavior of the connection depending on the client that you're using. Let's see. What else to say about caching headers? How about cookies? Is everybody basically comfortable with cookies? You get a response, you get an HTTP response, let's see, this one doesn't have them, or actually Chrome is going to strip those out, so we'll come back to that when we get to man in the middle. So you get an HTTP response that's got a cookie header, which stores some text, and then your browser saves that. Or if you're using curl, curl saves that. So if we do curl cookies, and then we hit google.com, Google will give us a, let's do capital L to follow the redirect. So now if we look at the Google cookies that we got, it's just text, right? Same as you would see in your browser console. And then you just send this text back. In curl, that's going to be a different flag. That's going to be the B flag. But that's you sending the cookie back when you make the next request. And that's one way to correlate an individual user with the server. But it's just text. There's nothing to stop you from modifying those cookies in the browser or to modifying the cookies in this text file, depending on what the cookie's doing. So you can dive in there and play around with it. But keep in mind, those are just sent as headers. So if you're troubleshooting something and you're not logged in, make sure that your request is sending the cookie header, like this. Let's see, what else can we talk about? Let's talk about the host header, but let's get into man-in-the-middle proxy first, because it'll come up. Well, I'll mention it briefly. The host header is an optional header that we can send. So if we don't, let's see, what do I want here? 8001. So most clients are going to add the host header by default, as we've seen. It's not required, but yeah, most clients are going to add it. And generally speaking, that host header is going to be the host that your request is trying to contact. But that doesn't necessarily correlate with the host name that you're actually hitting, especially if it's an IP address like this, right? Where that host header doesn't really mean anything at all. And so overriding that host header is something that's commonly done, especially when working with proxies or load balancers, where your request is going to go somewhere else after it makes that initial connection. And so that host header comes into play to say, I'm trying to hit example.com instead of example.net. And it's the server that looks that up. So a really common way to configure this is with Apache's virtual hosts, where you would configure your server to say, I'm listening on this IP address, name-based virtual host. I'm listening on this IP address, but if I get a request in for example.com, then serve it with this website. If I get a request for example.net, serve it with this other website. And so it's the server that's responsible for taking that host header and figuring out what to do with it. So we can do that with example.com. If you're not familiar with example.com or org or .net or whatever, this is just a top-level domain that's been reserved by the standards committee for you to use in examples, example documentation, example scripts. It doesn't do anything, and it's always on. And you can just hit it to run various things. So say like we make a curl request to example.com. Make that a little bit bigger. So you can see that we got a 200 OK back and example domain in the HTML exactly as we saw here. And example.com and .net and .org, they all return the same thing. So if we tell it to use a different header like host example.com, if we were to do something like that, then we would get the response back for example.com. It would see that host header and do that lookup. If we ask it for something that it's not serving, like Microsoft.com, it'll 404. It's not doing anything with that particular header. So the host header comes in quite handy, and we'll talk about that again in just a second. Any other questions? Okay, let's talk about man-in-the-middle proxy. So this is a really neat utility. It's Python. Don't hold that against it. But it's a quick install, and it's quick to get up and running with. And what it lets you do is set up a variety of proxy servers really, really easily, including using SSL certificates. And that, by itself, is huge. It's also all open source and free, which puts it a head and shoulders above a lot of the proxy offerings that are out there if you just Google for it. So it's a quick install. If you're on OS 10, it's just in brew. You install it, and that's it. There's nothing else to do. It's got a variety of command line or various interfaces. We'll talk about those as we go. Python API, which we'll talk about, which is nice, and yeah. So the docs. So once it's installed, you just start up the proxy, and there's a few different kinds of proxies that are worth talking about. So let's skip over here in the docs to modes of operation. And you don't have to know a lot about HTTP, but still be able to use it. This little flowchart makes it really nice. Do you want, can you do, and it'll kind of tell you what kind of proxy you need to be able to do. So say like we wanted to be able to use a proxy to log all of the traffic that our browser is sending to some remote server. That's the default mode of man-in-the-middle proxy, and it looks like this. So in a terminal, you start man-in-the-middle, and you've got a couple of options here. You can do proxy, which will start a CLI interface. We'll show that one in a minute, and man-in-the-middle web. So you hit enter, it starts up, and there it is, it's running. So you can see that the web server is listening on port 8081, so that's where we're looking at right here. And the proxy itself is listening on port 8080. So then what you need to do is you need to tell your computer. You say, I want to send all web requests through this proxy. And the way you do that is opening your system preferences. This is going to be the same on Mac, Linux, and Windows. You will configure the proxy for whatever internet connection you are using. Jump over to the Proxies tab. And then you've got Web Proxy and Secure Web Proxy. And so you turn both of these on, make sure that they're pointed to the right address and port. So you remember it was listening on 8080. And then you hit OK. If that didn't work, you're going to get a bunch of connection failed requests. But if it did work, now you're going to start getting a bunch of requests showing up in that tab. And if you've got a bunch of tabs open, there's probably going to be a lot of background stuff going on. So these are all of the HTTP requests that are happening just visiting Yahoo. So why would I do this? Why would I run man-in-the-middle proxy instead of just using the Chrome developer tools? Any guesses? Yeah, more detailed information. Great answer. Also, the Chrome developer tools will lie to you. So the Chrome developer tools are excellent in a lot of ways. They really are first-class development tools. So if we come to the network tab, they're going to serve us an awful lot of information. And they're going to do a few things. We've talked about in previous meetings this preserve log, preserve this network log across various 300 redirects, which is really nice. Disabling cache is really nice, especially for debugging client-side applications. And we can dive into a lot of information here. Now, some of the headers that are shown in, say, the request, for example, will be occasionally missing. So this one has cookie. We were looking before, and it was missing. But yeah, every so often you're going to find slight disparities between what actually goes over the wire and what shows up here in the log. Let's see if we can find a few. Some of this is interesting. So you can see this one here was a 200 OK response, but it was from the disk cache, meaning this request never actually hit the wire. We pulled it out of cache. And if you notice that here in the DevTools, great. If you're looking at this in something like man-in-the-middle proxy, you're just going to see the absence of that, right? And then this thing here. So this is something to watch out for in Chrome Developer Tools. Provisional headers are shown. This can show up here in request headers and response headers. Keep an eye out for it. I've spent more than a little time Googling around for what the exact definition, what this means when this shows up, and I have not found a direct answer. But as best I can tell, when this shows up, you should just be very suspicious of all of the information presented to you. Maybe it hit the wire, maybe it didn't, maybe parts of it are missing, maybe parts of it are cached. It's kind of up in the air, but keep an eye out for that because you're not seeing the whole story whenever that message pops up. In this case, it looks like it's pretty straightforward. From disk cache, provisional headers shown, but that's not always the case. Chrome has been moving functionality out of the network tab little by little. So you used to be able to go to about, is it net? Net internals. Used to be able to go here to see stuff that was actually going on the raw socket that Chrome was holding open, and that was really, really helpful for seeing what was actually going across the wire. But they've pulled this out even as well, and so now you have to turn on logging and you have to upload your log to this external service. But it's there if you ever need it. It's not useless, but they pulled it out of Chrome when it used to be just baked in. In addition to just not always getting the full story here. Oh, I just noticed I told it to disable cache, and we pulled something off of disk cache. So if I was debugging this, if I was a Yahoo developer debugging whatever problem this was causing, that would cause my spidey sense to tingle. But if we look on the in the man-in-the-middle proxy, we should see. So let's look at this this first one, this rapid.js. Let's see. Yeah. So man-in-the-middle proxy saw it, if I'm looking at the right thing. Nope, I'm not looking at the right thing. Okay, rapid.js. So man-in-the-middle proxy did not see it, so it did actually get pulled out of disk cache, even though we've told the developer tools to disable the cache. So that's, let's go with interesting. Can we go with interesting? Let's see. So anyway, when you're debugging HTTP, it's nice to have multiple perspectives on the same thing for exactly these kinds of questions. You're going to get a lot more detail that's going to show up in here. You can filter, you can highlight. I'm not going to go through how to use the man-in-the-middle proxy UI. There's a lot to go into here, but you can see it's got a lot of filtering options. The docs are really fleshed out. So yeah, it's a good thing to go through. Replaying can be useful. I tend not to work in environments where it's that useful. I think if you're doing server-side work, replaying a request or like modifying a request slightly and then replaying that modification might be a lot more useful. In a browser environment, you're usually dealing with cookies and authentication and that kind of thing, and navigating to a certain page, which makes that a little less straightforward. In any case, if you ever want to clear this log out, you can clear out the log itself, or you can just start over with a fresh session. Let's see. So this is proxying all of the requests that I'm making across all of my browser tabs. If I'm making secure requests, they can still show up here. And this is a really big deal. Not all proxies will do this. So you can see that these requests here, they're all HTTPS. And Yahoo, being a good web citizen nowadays, is all using HTTPS. And so all of these requests are secure. So in theory, man-in-the-middle proxy should not have access to the contents of these encrypted requests. But it does, because we can set it up to do so. And the way you do it is I'd encourage everybody to install this if you have this need of debugging HTTP requests. Install this after the meeting. It'll take you all of 3 minutes, and it'll be on your system, and you can just call it a day from there on out. So install the package, start man-in-the-middle web like we just did, point your proxy server to it, and then when you come in here, there's this link here, install certificates. And this takes you to this URL, which is not a URL. It's not a real URL. It's just something that man-in-the-middle proxy is configured to catch for you. And then you can install a certificate based on whatever device you happen to be running. So if you're running on a Mac like I am, click that. It'll give you instructions on how to install the certificate, and it'll download this custom certificate for you. So you need to put this on your system manually. You say, this is a trusted certificate, so go ahead and give me access to all of the things that are encrypted using the certificate. And once you do that, then your request hits man-in-the-middle proxy. It's got that certificate in place. It swaps it out with the actual request to Yahoo, and poof, you can see all of the secure requests that your browser is making to Slack, to Yahoo, whatever, right? If you've got the Slack tab open and you're debugging something, you're going to get a bunch of Slack noise in there. And it's all right there for you to just kind of poke at and learn from. It's super interesting. And not something you're supposed to be able to do, but it's just kind of a drop-in install with this software. Any questions about that? So, what else to talk about? Let's talk about a few of the other proxy types. So this one's nice to be able to see all of the traffic that your browser is sending to external servers. I've used this before with customer-facing servers. So what if our customer server, this bank over here was returning a specific response instead of what it's actually returning? How would that affect our application? And this lets me do that because it's an external server. But there's other ways to do it, like with a local development server.
Can you filter the noise on that? Can you say only these domains?
Yeah.
Track these domains?
Yeah, if you get in here, you can do by host. Let's see. Headers, domain. There we go. So you can do domain regex. Yeah. Otherwise it's just a ton of noise.
Yeah.
Okay, so I'm going to turn that proxy off. And when you're playing around with the regular proxy, as it's called, and you do this that we've already talked about, if you forget to turn this on or forget to turn this off, you're going to run into instances where, let's see, let me turn that back on, sorry. So say like you kill your proxy server, so we killed it there on the left-hand terminal. The OS level proxy is on, and now we try to go somewhere. It's going to work. Maybe I didn't actually turn that on. Oh, I didn't because I'm on wireless. Okay. So if you're playing with proxies and you ever get something like this, no internet, checking the proxy address or the state of the proxy is probably going to be the problem. So keep an eye out for that. Okay, so let's use a different kind of proxy now. This is going to be a reverse proxy. So this regular proxy that we were using is good for remote sites, as we've been talking about, but it's not going to pick up local stuff. So say like I'm developing locally, localhost 3000. I'm working on Robinhood to do normal MX stuff. That proxy is not going to pick up this traffic because it's all localhost. It's just hitting the local server before the proxy has a chance to pick it up. So for this, we can do something called a reverse proxy. And man-in-the-middle proxy makes this easy to use. So if we do man-in-the-middle web, and we pass this -- mode argument to it, we can say we're going to use a reverse proxy. So what we're going to do is we're going to listen on port 8002, but we're going to send all of that traffic to port 3000 on localhost. So if I do that, it'll open up this again. We don't have to turn on the system level proxy since we're just proxying that one address. And so now if I go to localhost 8002, it will be the same as this localhost 3000 that Robinhood and Longbow are listening on by default. So this is a nice way to be able to put something in between you and the local development server. And I'll tell you why this kind of stuff comes in handy. Troubleshooting, bug hunting, definitely. If you don't know how to make changes to the back end, this is a nice way to do little tweaks to test things. But it's also a nice way to just kind of change things and swap things out as well. And you can see all of these requests now show up here. So let's see. What else was I going to mention? Oh, and you can do that for any website. So if I kill that server and I start it up again, let's see. This time, let's listen on port 8002, but instead of proxying localhost 3000, let's proxy Microsoft.com. It's probably an S, and this should work for SSL as well. So if I go to localhost 8002, hopefully we'll get Microsoft.com. It looks like they had a redirect in there. So we'd have to fix our proxy to work with that redirect to keep us on localhost. If I do that again and preserve the log, we should see that in action. Localhost 8002. So yep, we got a 301 redirect. So I made a request to Microsoft.com, and it wanted me to go to HTTPS www. So we could write a script to take that into account, or we could just bake it into the initial forward. Let's see. Yeah, let's try that. Clear out our log, see what happens. Localhost 8002. Nope, still got the redirect. Anyway, I won't troubleshoot that in front of you, but we'd want our proxy to bake that in. Actually, we can play around with Robinhood and do that exact same thing when we get into the scripting part. So that's a nice way to say how would the client-side application that I'm building react differently if I could get Microsoft.com to return this specific header for me. If it was returning this cache header or this additional custom header, would that work with my authentication scheme, or how would that affect caching in the browser, or that kind of a thing? And so that lets you modify a server that you don't own with custom stuff that is relevant to whatever it is you're building. So that's a nice way to mess around with external servers or servers you can't or don't own. This reverse proxy. Let's see. Any questions about that before we talk about scripting? Okay. So say like we had a redirect in place. Let's do this with Robinhood because I've done it previously, so it'll hopefully go smooth. Let's log out. Okay. So with Robinhood, if I am logged out, I need to go through this login step, and this login step has a redirect in place. So if I change the reverse proxy here, sorry, I can't see that with Zoom. So let's do what we were doing before. HTTP localhost 3000. Yep. Okay. So we're proxying our local Robinhood server. So now if I go to localhost 8002, let me open my network tab, and I'm preserving the log here because I know it's going to give me a redirect. So it tried to redirect me to localhost without the domain. So this is going to kind of step on my toes a little bit as I'm trying to figure out whatever it is I'm trying to figure out. So you can see that I got this 302 back. It's trying to send me to localhost and then the sign in. So it stripped out the port for whatever reason. That redirect in our client-side code stripped out that port. So what if I wanted to just artificially add it back? I could get the server guys to fix it, assuming that's a relevant fix, but probably has dubious usefulness to the rest of MX. I'm just trying to troubleshoot a thing, so I just want to fix that one thing. So you can write these little Python scripts and load them in, and they're really straightforward to write. The docs are pretty good. They show you all of the hooks, what do I call that, long cache. So say like you wanted to modify the cache headers or something like that. Oh, nice, I already left the location stuff in here. So this is what it looks like. You write a class, you've got a request or response method in that class. There's a bunch of other methods that are available, which you can see if you come to the docs here and go to add-ons. So let's see, I guess I wanted events. So here's all the supported events that your class can have. So request headers, the initial connect, response headers, the response, any errors, TCP level stuff, webhook level stuff. So there's a bunch of hooks that you can code to, but they're straightforward to write. Say like we wanted to add this expires header, but we've got this this redirect in place, so we want to fix that. So in our response, we're just going to check to see if our response header has a location header, and if that header is equal to this this value. Let's rewrite it so that it's got a port in there. So we're just going to set the location header with that rewritten header with the port. That's it. And obviously, this is all Python. You can get as granular as you want to in here. So if we save that out, now we can run our man-in-the-middle proxy with script on cache.py. Starts up as usual. And so now, if we were to hit localhost 8002, it works, and you can see we got that initial 302, but this time the location header in the response has been rewritten with the port like we wanted it to. So we made that change, and it was just a drop-in. We didn't have to think about that too much. So now we can continue troubleshooting whatever it is we were troubleshooting. So that's a nice way to modify the response, convert it to JSON, add a header, fix a weird accept header. I guess we didn't talk about those. Accept headers are kind of neat. They let you do content negotiation. So when you make a request, you say, these are all of the content types that this client can process. You can give me JSON, or you can give me YAML, or you can give me whatever. And then the server sees that and says, oh, well, I'm going to try and tailor my response to what the client asked for. That's what browsers do to determine whether or not you're asking for HTML or XHTML or whatever else. So it's kind of a fun thing to play around with. On that note, if you're ever writing a REST API, you can do an awful lot with HTTP headers. You can do pagination, you can do crazy things with caching, you can do things with conditional gets, you can do things with content types, and it's a lot of fun to play around with. And oftentimes, as application developers, it's just easier to stick with familiar territory and like append all of that stuff to query string parameters in the URL. But HTTP is surprisingly capable and can do a lot of things. There's a reason it's stood the test of time. So it's a lot of fun to play with if you ever have the time or the use case. So that brings us to the end. We've talked about everything, all of the selling points of man-in-the-middle proxy. Install it. You can get up and running in 5 minutes. So give it a shot and give me a ping on Slack if you ever have any questions about it. Happy to play around with it. And thanks for coming.
Thanks.
because with React Native, there's no really good way to test traffic.
Really?
There's no they're still building out the tools for that. So this is beautiful.
Wow.
So I
Yeah.
can now test network traffic for my React Native stuff.
That's awesome. I want to hear how it goes.
So yeah, I will. Let you know.
Isaiah, are you using React Native Debugger?
What's that?
Are you using React Native Debugger? Network test?